Greetings, everyone. Welcome to the session today. What we're going to be looking at, as the goal states down here at the bottom, is to use factoring methods to solve a special type of equation that comes up often. A special type of equation called a quadratic equation. So first of all, what I'm going to do is show you what a quadratic equation looks like. And then we will use the factoring methods from class to solve one of these things. So first, what does it look like? If you take a look at the slide here, quadratic equations usually look like this, where they have an x squared term, they have an x term, and then a lone number at the end, equal to 0. That is, when it's set up in a useful way, we have the x is going down in the order of the power. So it starts with a 2, x to the power of 2, then x to the power of 1, then x to the power of none. And lastly, it's set up so that x equals 0. This way is meaningful for us. Okay, the way to see that you have a quadratic is that the highest exponent is a power of 2, as we have here in the example there. Now, what you're going to see, so when you look at other questions and other sources, is that you might see the quadratic equation written like this, where you have a x squared plus bx plus c is equal to 0. So ABC, all they represent are numbers in the front. And if you recall, the numbers in the front like that, those are given the special mathematical name of coefficients. So in the example we have up on the slide there, the invisible 1 is in front of x squared. So a will equal 1. The letter, or the number rather, in front of x is a 5. In front of x is a 5. So b would equal 5 in this situation. And lastly, the number at the end is c. So in this situation, c would equal 6. All right, now, for today, we won't be using this so much. This will come up with other topics, but it's going to come up with you, as I said, possibly look at other sources and such. Okay, now, one other thing that can happen is that, importantly, the values of b or c could equal 0. So watch this. You might have an equation that looks like this, a quadratic equation, that is. Watch, this is still a quadratic. Okay. In this case, the letter in the very front, or the value in the very front, is still a. A is equal to 1. B is equal to 3. And notice there is no number at the end there. So it's like an invisible plus 0. So c would equal 0. Is this thing still a quadratic? Yes, because it has a highest power there of 2. Alright, so let's continue on then. Looking at the slide, the goal of this, given an equation like this, the goal is to find the values of x that will make this expression equal 0. That's just like solving any equation. Find the magic value of x that works. Now for the language is you say solve for the variable x, or solve the equation. Those are the sort of words you can expect to tell you what to do. Now, in order to solve one of these things, really all that's happening is you can summarize it like a recipe here. On the screen there, you can see there's 1, 2, 3, 4 steps. But really, you can combine those steps or write these steps. It's really only 2. Namely these ones. You factor the equation, or I guess the expression. We're solving the equation. Factor the expression and solve each factor for x. Okay, so we have those 4 steps there, and they're all important. But really, once you get the hang of it, these are the bits that you need to know. And this we've done already. We've practiced that with the different methods. So the only thing we're doing, the only thing really that's new today, is adding on this one extra step at the end. So with the equation that's there, the x squared plus 5x plus 6, let's work it out with these 1, 2, 3, 4 steps in order to get some practice here. So step number 1 is the setup, or rearrange, right? So the way it looks is perfect. We have the equation written there so that it equals to 0. What might happen is that you might have the original question set up like this. You see, everything's... Oops, I'm going to make that as a minus so that it works. So everything's in order, of course, but the equal sign is in the way. What you want to do is have everything on the one side so that it equals 0. So you're going to have to use your rules of algebra in order to rearrange it so that it looks proper-like. And that means pulling the -6 over to the other side. And of course, when you do that, it changes sign when it crosses the equals sign there. And now it's set up in a good-looking way that's useful. We can see what A, B, and C are. It's x squared x and then the number at the end. Okay, this is how we want it to look. Number 2 now. Because of all the practice that we've done, you just factor it. Okay, whatever it is you're looking at, there are some special things to do. So because it's 3 terms like this, what we want to do is find 2 numbers that multiply to 6 and also add up to 5. And hopefully you beat me by now. Doing this, you'll see you get an answer of x plus 2 and x plus 3. Okay, so we factored the quadratic expression that we have there. And earlier on, this is where we left it. Okay, this is where we finished. Really, because this step here, as you saw, can be quite challenging for big numbers, pluses and minuses, fractions, all those things. But here's the extra bit. Okay, we have it equal to 0 in this particular question. So, these are the extra pieces now for today. I said the extra step, I'm combining into 2 down here, 3 and 4. what you do is you set each factor equal to 0. And these arrows are nice. They're going to trigger your brain and go like, oh yeah, okay. I get to this point here. We need the result equal to 0. So one of these has to equal 0. So you set it up like that. You go x plus 2 equals 0. And then the fourth step is to actually solve for x. So we'll do that in the next step. We set this factor equal to 0, the one bracket. Set the other bracket equal to 0. Okay. Now, it's important to do so. In this question, once you see how the answers work, you probably just want to skip right to the end. But once you start getting other numbers in here, pluses and minuses, maybe a 3x instead of just an x. Okay, once you start getting other numbers in there, I recommend doing this step so that you do the algebra carefully and properly in order to get to the end. Now, do it fast, of course, right? But careful first. Okay, so we have these factors each now set up equal to 0. So now you solve each of them. And what do you do for this? Pull the 2 over. X is equal to negative 2. What do you do here? Goes over. X is equal to negative 3. Once we have these x values at the end, finished. That is the goal of solving a quadratic. Getting the x values that will make the original question equal to 0 when you substitute these in there. Let's now try another example. Here we have this quadratic to solve. As it shows, it says solve for x. So, okay, we'll go through the steps in order to make that happen. 1, 2, 3, 4. Factor this thing. And then set each factor to 0 and work it out. So how do you factor one of these? Well, because there's a number in front, the first step is to multiply the first number and the last number together. Okay, and so what we need now, as usual, we're going to find our two numbers that add up to 5x. Okay, but here's, we have to work with 3 times 2. So here's how you do it. Or this is one way. With factoring, there's no shortage of ways to do it. There's 3 times 2, first number times the last number. That gives you a 6. Okay, so now, what we need to do, we can do, pretend this is off to the side. Got to do that. Now what we need are two numbers that add up to 5, and those same two numbers have to multiply and equal 6. The number we got from multiplying the first and last numbers together. Okay, so what numbers could we try? Well, 1 times 6 gives you 6, but 1 plus 6 gives you 7. So that doesn't work. But in this particular question, let's see. What other possibilities are there for multiplying to 6? 1 times 6, 2 times 3 as well. So if we have 2 times 3, that gives you 6. And notice, 2 plus 3 gives you 5. Hey, so in fact, those are the ones that we want. That is, those are the numbers that will help factor this expression here. So, reminder, what do you do with them? You use these numbers to replace the term with x there. So we're going to use these two numbers to replace the 5x. So watch. 3x squared stays the same. Plus 2 stays the same. Equals 0 stays the same because that's the question. But instead of 5x, we're going to use these numbers here. And just for fun, I'm going to write them in this order, just to prove the, just to show you something like that. Okay, so definitely 2x plus 3x is 5x. That's okay. So, how to move forward? Well, with 4 terms there, we factor by grouping. Hopefully you've recognized that, but just as a reminder, factor by grouping, which means a common factor from each pair of terms. Oh, and not just a common factor, but the most awesome common factor, the greatest common factor, okay, from each pair of terms. So looking at the first two, the only common factor there, nothing from the numbers. 3 and 2, they don't get along. Nothing in common there. But the x's, though, you can pull out an x. And that creates now, remember once you have it, you divide each term by x. 3x squared divided by x, the GCF. 3x squared divided by x is 3x. 2x divided by x, plus 2. Same style over here with the next one. As in, pull out the GCF from this pair here. Well, nothing from the numbers. 2 and 3, nothing in common. And here with the variables, x, there's no x. So really all you can do in that situation is pull out an invisible 1, which you can see right there. Do the dividing to get the inside. 3x divided by 1, 3x. 2 divided by 1, plus 2. All right, beautiful. Now, we have something appearing in this first part, and that same thing appearing in the next part. So that counts as a big common factor. This 3x plus 2, which is here and also there. Okay, so you pull out that common factor now. And as usual, that goes to the front. And then to get what's left on the inside, you could divide in your head. Divide this first term by 3x plus 2, cancels out, left with the x only. You divide this by 3x plus 2, the common factor we get, left with plus 1 only. Beautiful. So this is where we got to before. Factoring our expression. Okay, but now we have a little extra to do. The extra equal to 0. The extra. Put this equal to 0, this factor equal to 0, solve. Put this factor equal to 0, solve. You do that, the good work looks like this then. Oh yeah, the arrows. Very nice trigger. The arrows to do what? That first factor. Notice the brackets can disappear there. Equals 0. The other factor. Do this at the same time. Recommended. Solve now for x. See? Maybe not so nice. Yeah, maybe you can. But I think it's better when it's written out like this. Instead of risking a mistake in your brain, do it by hand here. So 3x equals negative 2. Divide those sides by 3. Minus 2 over 3. Like that. The other example, to get x by itself, you pull the 1 over. Becomes negative. You get that result. So what do we got? Start at the very beginning. Factored to get these factors here as usual. Then we did the extra step of solving each of these. That is setting to 0 and working out what x is. And that creates this value here, which is one of our final answers, and this answer here, which is another of our final answers. So, what was seen today? Beautiful, good work. What was seen today was the challenge of finding the solution to a special type of equation called a quadratic. How do you do it? You make sure it's set up so that it looks good. Set up with the proper style so that it's useful. Next, you factor as usual. And then the extra step is set each factor to 0 and solve. You do the work carefully, and you'll be successful every time you encounter a question like this. All right, good people. Thank you for stopping by. Hope you had fun as I did. Please practice some questions, and I'll see you at the next session. You take care until then.